Hey everyone, welcome back to my channel. Today, we're going to talk about the book, A Brief History of Time, which chronicles humanity's exploration of the origins of the universe. Let's decode this masterpiece together. A Brief History of Time is the seminal work of physicist Stephen Hawking. Since its first publication in 1988, this book has been a global bestseller, translated into more than 40 languages, and is one of the most popular science books of our time. Despite suffering from amyotrophic lateral sclerosis, Hawking remained active in the forefront of scientific research and made significant contributions to contemporary cosmology. A Brief History of Time documents his thoughts and insights on the origin of the universe. The book is divided into 3 parts. The first part reviews the history of human understanding of the universe, from the geocentric model to the heliocentric model and the modern theory of the Big Bang. The second part provides an overview of the development of physics, from classical physics to relativity and quantum mechanics, which laid the foundation for modern cosmology. The third part elaborates on Hawking's own research on black holes. First, let's take a look at the history of human understanding of the universe. Several hundred years before the Common Era, the ancient Greeks proposed the flat Earth theory, believing that the ground beneath us was a flat disk. Around 200 BCE, a group of Greek astronomers introduced the geocentric model, which stated that all things revolved around the Earth. Later, in the 15th century, Polish astronomer Nicolaus Copernicus proposed the heliocentric model, suggesting that the Earth and other planets revolve around the Sun. In the 17th century, Galileo further confirmed the heliocentric model. 100 years after the confirmation of the heliocentric model, British physicist Isaac Newton presented his law of universal gravitation, laying the foundation for classical physics. Newton believed that the universe was infinite and that the various celestial bodies were held in balance by gravity, resulting in an overall static universe. After Newton, 2 groundbreaking theories in physics emerged, directly challenging the human worldview. These are relativity and quantum mechanics. Let's first look at relativity. In 1905, Albert Einstein introduced the theory of special relativity, which connected time and space. In 1915, he proposed the theory of general relativity, suggesting that space and time could be curved. In the early 20th century, Einstein proposed the theory of general relativity, which predicted the expansion of the universe. Later, scientists discovered that if we trace back to 15 billion years ago, the entire universe would shrink to an infinitely dense singularity. Hawking and mathematician Roger Penrose proved that if relativity is correct, the universe must have originated from this singularity in a Big Bang. This is the famous Singularity theorem. Singularity is infinitely dense, and all known laws break down there. This implies the limitations of relativity and leaves room for the creation of the universe by a higher power. Next, let's explore Hawking's proposed model of an unbounded universe. The mainstream model suggests that the universe has a starting point and a boundary. However, Hawking proposed the model of an unbounded universe. The universe is finite but without boundaries, without a starting point, and does not require a creation by a higher power. Hawking incorporated quantum mechanics into relativity, suggesting that 4-dimensional spacetime is closed yet unbounded, similar to the surface of the Earth. This means the universe has no starting point, no singularities in the laws of physics, and no moment of creation by a higher power. Finally, let's discuss the Hawking radiation discovered by Hawking. Black holes have such strong gravity that even light cannot escape, appearing completely dark. However, Hawking pointed out that according to quantum mechanics, particle pairs are generated at the edge of a black hole, with negative energy particles being absorbed while positive energy particles escape. To an outside observer, it appears as if the black hole is emitting radiation, known as Hawking radiation. The theory of Hawking radiation ingeniously combines relativity, quantum mechanics, and thermodynamics, representing one of his most important contributions. Hawking's contemplation on the origin of the universe completely revolutionized the human worldview and has propelled the progress of modern physics. A Brief History of Time provides the public with a fresh perspective, allowing us to understand that the universe operates in ways beyond our imagination. It broadens the horizons of ordinary readers and allows us to catch a glimpse of the mysteries of this vast universe. If you are also captivated by the expanse of the cosmos, then I highly recommend that you read this globally best-selling scientific work. Thanks for watching. If you enjoyed this video, give it a thumbs up and share it with your friends, and remember to subscribe to stay updated with future videos.